Getter and setter methods. In this video, we will begin learning how to add behavior, instance methods to our classes. Earlier in this unit, we demonstrated how instance variables can be accessed directly through the dot operator. For example, if I wanted to set the length of a rectangle to 10, I would simply type rec.length equals 10. And if I wanted to use the values of length and width in my program, for example, to compute the area, I would just write out rec.length times rec.width. The reason this approach is allowed is because both length and width are public by default. Even though we never wrote out the words public for length and width, when you don't write anything in front of it, instance variables are made public by default. Thus, not writing anything would have been the same as actually writing the words public in front of it. They both achieve the same effect. That being said, this is not safe programming. It is not safe for instance variables to be public. And here's why. Suppose I were to write a line of code that says set rec.length equal to -5. The compiler will have no problem with this because, hey, the length is an integer, -5 is an integer value, thus no problem, no reason to raise a red flag. However, this is not how we intended the length and width variables to be used. We as humans know that a rectangle cannot have negative width or negative length. So even though the compiler allows this, we know this is incorrect. However, when instance variables are public, it's hard to prevent this kind of error from happening. Hence why instance variables as a rule are always made private. By making them private, we are no longer allowed to directly access instance variables through the dot operator. This helps prevent those kind of mistakes from happening. Also, as a rule, is to make constructors public. We do this because if constructors were made private, then we would not be able to create rectangle objects in our program. Henceforth, since we want to be able to create objects, constructors are always public. That being said, I'm going to leave it off since constructors are public by default. Now, going back to the instance variables, now that the instance variables are private, these two lines of code are now compile errors. This program would not be able to successfully compile because we would get an error message telling us that these members are private and thus we cannot access them. That all being said, although we want to keep these values private for their safety, we are eventually going to want to use them in our program somehow. How can we do that safely? This is where getter methods come in. All right. Now, before I explain how to make a getter method, notice that I erased the code for the instance variables and the constructor. I'm erasing it from the video screen. I'm not erasing it from the program. I'm just erasing it from the computer screen just to give me more space to write additional code. Now, to the getter method. How do we write a getter method? First rule of thumb, getter methods are always public. Next, the return type. The return type for a getter method always matches the type for the type of variable that we're trying to get. In this case, we're trying to get the length variable, so the return type is going to be an int because that's the type for the length instance variable. Then the name, the method name. The name always begins with the word get, followed by the name of the variable we're trying to retrieve, which in this case is length. So the name of the method is going to be getLength, followed by an empty set of parentheses. Getter methods always have an empty parameter list. They receive no parameters. Then inside the body of the getLength method, we simply return the length. We simply return the instance variable that we're trying to retrieve. Same rules goes for retrieving the width variable. Once again, public, getter method is always public. The return type should be the same as the variable we're trying to retrieve, which in this case is the int. Then the name of the method, get, followed by the name of the variable we're trying to retrieve, width, followed by an empty set of parentheses. Then inside the body, we simply return the variable that we're trying to retrieve, which in this case is width. Then inside my main method, when I create a rectangle object, if I want to use the length and width variables inside of my program, rather than accessing it directly like as I was before, I can use my getter methods, getLength and getWidth. That all being said, something else that's inevitable in our program is that we are eventually going to want to be able to change the length and width of our rectangle. But with the length and width variables being private, how can we do that safely? This is where setter methods come in. What are the rules for setter methods? Well, just like getter methods, they're always public. The return type is always void, no matter which variable you're trying to change. That's because the job of a setter method is simply to modify the variable, not to return it. So, return type always void. Then the method name always begins with the word set, followed by the name of the variable we're trying to modify, which in this case is length. So the method name will be set length. And then the parameter list will always consist of just one parameter, where the type always matches the data type of the instance variable we're trying to modify, which in this case is an int, because the length is an int. Then inside the body of the setter method, we assign that parameter to the instance variable. This.length equals length. This is the basic form of a setter method. This is the basic responsibility of a setter method. That being said, setter methods also have one other special capability. Okay? Setter methods have the ability to check the parameter to ensure that it is valid before storing it inside the instance variable. How can it do that? Well, we start off by making an if statement. The purpose of the if statement is to check and make sure that the parameter has a valid value. Well, what would make the value of the parameter invalid? Well, if length is less than or equal to 0. Like we discussed earlier, rectangles cannot have a negative length. They cannot have 0 length. Thus, if the length is less than or equal to 0, throw an exception. We're going to throw an exception with an error message saying invalid length. And what this does is that anytime an invalid value gets given to the setLength method, the programmer, the user of the program, will be notified, rather than that bad value simply being stored and then the programmer continuing on about his business as if nothing bad happened. No, in this case, we're going to be notified. We're going to receive an error message. Then, if the condition is false, or in other words, if the length value is valid, then we will store inside the parameter. This, combined with the fact that instance variables are private, helps to ensure that only appropriate values get stored inside the parameter. Okay? And the same approach can be used for setting the width. Once again, public, void, set width, one parameter. Use the if statement to make sure that the value is valid. If it's not, if it's less than or equal to 0, throw an exception with the error message invalid width. If it is a valid value, then store the parameter inside the width variable. Okay? With that code written inside our main method, if we attempt to put a negative value inside a rectangle, when we execute the program, an exception will get thrown. We'll receive an error message letting us know that an invalid value was given to the setWidth method. And if we pass a positive value, a valid value to the method, well, we'll receive no error message. The value will simply get stored inside the width, and there'll be no issues.